So I'm Anna Watson. I worked under Janet this summer, and my project was looking at the world salt effects specifically in Montague, Michigan. So a little bit about me first. I'm an environmental and sustainability studies major at Grand Valley. I have an emphasis in water resources and culture and the built environment, a minor in business, and a certificate in GIS. My project this summer was looking at road salts, but I also had the privilege of being on the beach monitoring team once a week. I reported data to websites like SaltWatch, did some Muskegon Lake monitoring, and helped with classroom preparation, and wrote a paper. So it's a little bit all over the place. So how did I get involved in the road salt project? I took my senior capstone class as a junior this past year, and Jeff Ock, the Montague city manager, reached out to Grand Valley and was hoping to make their city more sustainable. So he asked for our capstone class to take on the project of looking at what measures they currently have in place and what practices they're doing and how they can become more sustainable. And my group looked at stormwater control specifically. As a part of our class, we took a tour of Montague and we noticed the steep hills and steep terrain. So we asked Jeff if there was ever reported problems with chloride levels or road salts. And he said that several residents, as well as himself, had noticed that in areas where there's heavy runoff, the vegetation takes much longer to grow back after the winter comes in into even the summer months. So I wanted to take that a little bit further, and I mentioned that in my application to AWRI that I wanted to work on this project. And luckily we were able to make it happen, which is awesome. So for my project, I looked at chloride levels in White Lake and Lake Michigan. I compared White Lake levels to the Grand River levels that I got from the wastewater treatment plant. And then I also wanted to look at areas for improvement for Montague that I could report back to Jeff, specifically with stormwater control and chlorides. So why should we be concerned about road salts in the first place? Chlorides affect aquatic life very heavily. About 10% of aquatic life is negatively affected by chloride concentrations. Plankton are especially sensitive to chlorides, and as you all know, they're very important in ecosystems and food chains. Chlorides also interfere with osmoregulation, which is what controls salts and other solutes in aquatic species. Chlorides can prevent reproduction and spawning from happening. They're harmful to vegetation with bounce and scatter, and the runoff can also be taken up through plant roots, which is damaging. Soils can be damaged themselves too. Fertility and permeability can be reduced. Their ability to retain water can be reduced. And if there's enough chloride in the soils, it can actually draw water out of the plants, which then puts them in drought-like conditions and often can kill them off in certain situations. In extreme levels, chlorides can prevent lakes from mixing, which is very harmful for aquatic species. Corrosion and infrastructure damage from chlorides, and then chlorides can also enter groundwater, which is heavily relied on for drinking, and this can lead to health effects in humans, such as like heart disease, high blood pressure, and even strokes. So salt enters the environment during all stages: storage, transportation, and application. Application is probably most common known with bounce and scatter. But storage is also a big problem. There's many situations where salts aren't stored correctly, like in that salt pile that's just open to the elements. And a study done in Rhode Island found that piles like that can lose up to 20% of their salts just by precipitation or wind. And then chlorides also enter the environment through wastewater. The human diet has become very much so salty. So that ends up in wastewater, which ends up in the environment, and water softeners also use salts. And the wastewater treatment plants don't deal with chlorides because it is expensive and they're not considered toxic until they reach a certain level. So they're often not dealt with. So what is that level? It's 230 milligrams per liter or more for 4 days, or 860 for more than an hour. So these are the sites I looked at in Montague. The Campground drain site the drain that's at Old Channel Trail and Strong Street intersection, the bridge that connects Whitehall on this side and Montague on this side and goes over White Lake. Then Lake Michigan at Medbury Park, and then the Law Road boat launch, and that is right before the channel that goes out to Lake Michigan from White Lake. And then this is all of them on the map of White Lake. So the bridge and the drains are up this way. Medbury Park is down here. The Law Road boat launch is right there. And then I wanted to look at a drain that's right here, but due to the equipment I had, it was going to be unsafe for me to test that site. So unfortunately, I didn't have a site in the middle of White Lake. And then these are the methods that I used. I used chloride strips to test for chloride, and then a conductivity meter to test for conductivity. And then this is the data I collected. You can see that a lot of them say less than 32 ppm. And that is because the chloride strips that I had were low range, but the chloride levels were low enough that they weren't even, there wasn't a conversion factor to ppms through the hot chloride strips, which is a great thing for White Lake. And then the highest level I got was 45 ppm, which is still much lower than the 230 that's considered toxic. And then this is the conductivity that I had. There was two very high values, 1450 and 1390. And but those sites on the same days, same place had very low chloride levels. So it's likely that there was another pollutant in the water at that time that had the levels become that high. The two non-available data, that is because it was so windy that day that the water was crashing right over the pier and probably would have been swept away if I had tried to test those sites. So another thing I looked at was correlation between chloride and conductivity. Since the chloride levels were so low in White Lake, it was hard for me to make any kind of conclusion with the data set that I had on the White Lake levels specifically. But I also looked at the Grand River data, like I mentioned, and there was several data sets there from different tributaries that showed a positive correlation between them. So the top line is conductivity, the blue line, and the orange line is chloride. You can see that they rise and fall in similar places and peak at the same times, and then have valleys in the same places as well. And then another thing I looked at in my paper, I guess specifically, was the fact that my levels in White Lake were so low, but there have been many reports of concern by residents. And I think that that was because I tested in the summer months only. I only had a short testing time from beginning of June to the end of July. Whereas I think if I would have tested in the winter months also, I would have seen much more of a rise and fall. And the Grand River data kind of proved that for me. So you can see that like this is December, which is very high, and then it drops in June, and then this is another low in June, another high in December to March. So it rose with the winter into the melting season, and then fell in the summer and then the fall. And then as a part of my project, I wanted to report back to Jeff Ock with a few solutions. So the solutions that I came up with were using the correct type of road salt, a lot of, not so much on the main roads, but just in residents and businesses. Montague has a lot of urban residential areas that are non-pervious. So using sodium chloride is only effective in 16 degrees Fahrenheit or warmer, which is not commonly known among the public. And then calcium chloride and magnesium chloride operate in lower temperatures. So that's one thing that they could improve on. Also using pre-wetting. Brine is a common pre-wetting practice, and that's just adding a liquid to the road salts, which helps it adhere to the road better and reduces bounce and scatter. So pre-wetting roads with brine has been found to be, you can use 50% less road salt when you brine the roads first. And then monitoring the speed of application to make sure that there's less bounce and scatter. Calibrating equipment is very important. And then using salt tolerant vegetation in those areas where there was heavy runoff could improve absorbing some of those chlorides and the runoff water before it enters White Lake. even though White Lake did not have a huge problem from the data that I collected this summer. And then using proper salt storage, like I mentioned, if it's just open to the elements, it can lose a lot into the environment. And then educating the public, again, on like what salts that they should be using. And there's also many other things that they could do, like sweeping up the salt before precipitation event happens again, and stuff like that. Here are some of my sources. And I would like to thank Janet and Christina for helping me throughout this whole project, and the beach monitoring team for letting me be a part of you guys' research, and just everyone else who made my experience here great. So, thank you. For Anna.
Did you look at all into like, because my project was also on road salt, so this is really interesting to me.
Cool.
But did you look at all into like beet juice and other organic solutions for using road salt?
I did. I found that those are very contradictory depending on what article you're kind of reading. I know that Montague doesn't use any of those, like beet juice or another one. There's other additives that you can use. So I didn't look specifically at Montague, but in the articles I read, there's a lot of contradiction because those have a lot of sugars in them and stuff like that, which also attracts animals to the roadways, which can be another problem. But then again, salts could also be attracting other animals to the roadways. So it's just kind of, there's not a firm conclusion, I think, there on what would be best. But I have found that brining is a best management practice in comparison to the additives. Yeah, so. Yeah.
Could you go back to the graph of the plaster creek?
Yes. So I know the dates are kind of hard to read for some people.
Right. I was just curious because I live off of Plaster Creek. So do you know if there's anything like because those chloride levels that's like 500, right?
Yeah.
Do you know if they have any kind of restoration plan for that?
Actually, I do. The Grand River data was much higher in chloride levels compared to White Lake, but then again, they have data going back to like the 80s. So they've been testing for much longer, and that's right around like downtown Grand Rapids, so a lot more road salts are used there. I know that there is a Plaster Creek watershed partnership, and it's run by Calvin University actually, and they do a lot of restoration projects and stuff like that. Which is, I believe it started somewhere between like 2010 and 2018, somewhere, and you can see that the levels were very high and they are becoming a little bit lower. I know that they help like plant native plants that are salt tolerant around that area and around the watershed. So I know there's a little bit work being done there. Yeah.
Any other questions?